Hi everybody. One thing that we're going to do on the first day of class is try to determine why it's important to study statistics. And one way that I'm going to help you understand why it's important to study statistics is by bringing up three different examples. And these are examples that are relatively interesting. We're going to talk about lotteries, lifespans, and pirates. So what I want you to do is just watch this video, listen to what I have to say about these basic issues. I'm going to ask you a couple questions and then be prepared to talk about it in class. So it'll just save us time. So let's get started. First, let's talk about lotteries. Think about the Ohio lottery. Like, it's a big game. Lots of people play. You can win millions of dollars. My question to you, what's the probability of you specifically winning the Ohio lottery this week? And when we think about probability, we typically refer to probabilities in terms of like being high or probabilities in terms of being low. I'm not asking you to actually compute the probability of you winning this particular lottery. But I just want you to tell me, is the probability of you winning the lottery this week high, meaning there's a good chance, or is the probability low, meaning there's not so good of a chance? And then let's contrast that question with a similar but different question. What's the probability of someone winning the Ohio lottery this week? Would the probability be high or would the probability be low? And let's take this a step further as well. What's the probability of you winning the Ohio lottery twice? I know it's kind of hard to even imagine, but what would be the probability of you winning the Ohio lottery twice? Would the probability be high or the probability be low? And we will contrast that with a similar question again. What's the probability of someone winning the Ohio lottery twice? All right, so give that a little bit of thought. Let's move on to the next topic. Next thing I want to talk about, I found pretty interesting. I was looking through the paper and I was looking through the obituary section of the local paper, the Zanesville Times-Recorder, and I started thinking about average lifespans for people in different areas, different cultures. And I was wondering specifically about the average lifespan for people who live in Zanesville. You know, people who live in different areas, they engage in different activities. People in different areas have better health or worse health, whatever it might be. So I was interested specifically in the average lifespan for people who live in the Zanesville area. So the way I decided to conduct my research was to essentially look at that page of obituaries and then compute an average age based on the people who were listed. And on that specific day, there were, let's see here, 1, 2, 3, 4, 5, 6, 7, 8 people listed who had died. And their ages are typically listed. So one person was 63, one person was 55, 47. Sadly, there was an infant listed, and what I decided to do for my data set was list that as an age of 1. Another person was 48, 37, 55, and 50. So those are the different ages. So if I want to compute an average, just a simple average, I can use this formula to compute it. And we're going to learn about summation notation. Averages are nothing new for you. You've been computing them since you were probably in 2nd or 3rd grade. And all this really tells us to do is sum up all of the data, sum up all of this data, and then divide by the number of pieces of data we have. And we had 8 pieces of data. So let's do this together. I'll pull out this little calculator. If we take 63, and then we add 55, and add 47, add 1, add 48, add 37, add 55, and add 50. That will equal 356. Now we want to divide that by 1, 2, 3, 4, 5, 6, 7, 8. We have 8 different data points. So I'm going to divide by 8. That equals 44.5. Okay? So back to our data here. 44.5 is the average age that I computed for Zanesvillian. So my conclusion is that the average Zanesvillian lives to be only 44.5 years old, which I'm sure we would all agree is very young. So my question to you is, do you think my conclusion is appropriate? Give that a little bit of thought. We'll talk about that on the first day of class. let's switch gears again, talk about another topic. This one's kind of fun. Think about this summer. It's been really hot. And in fact, we've had several hot summers over the past several years. And check out this data. Here I have average global surface temperatures in Celsius since 1800. And I've plotted them on this graph. So back in 1800, the average global temperature was about 14.25 degrees Celsius. And we can see that over the years, here we have 1840, 1880, 1920, and we're moving right along to the year 2000. We can see there has been a steady increase in the average global temperature. Okay. Now what I'm going to do in kind of this next slide is add some information. So let me explain it as I do it here. What I've added here are the number of pirates in those years. Now, I don't want to confuse anybody, so let me go over this again. Here I just took the years and now I put them right up here on the trend line. So 1800, and again, we saw that the average temperature was about 14.25. 1840, 1880, 1920, we can see that average temperature line kept increasing. But what I listed down here now associated with those years and those temperatures is approximately the number of pirates that were working full-time in our seas, in the seas across the globe at that point, about 35,000 back in the year 1800. In 1840, there were about 20,000 pirates. Again, we see that the average temperature is increasing here slowly, and look at what's happening to the average approximate number of pirates, about 15,000 in 1880, 1920 about 5,000, and in the year 2000, not that long ago, estimating about 17 full-time pirates operating in the seas around our world. They do still exist. If you listen to the news every now and then, you'll hear about some ship being taken over by pirates or looted, robbed by pirates. But there are only 17 now. So my point is, we're seeing that as the average temperature increases, the number of pirates is decreasing. So here's just a basic summary. As the temperature increases, the number of pirates decreases. We call that a negative correlation. So as one variable is increasing, as the temperature is increasing, this other variable, number of pirates, is decreasing. All right, and to me, it seems to make really clear, obvious sense that as this temperature keeps increasing, it's really hard to be outside and on the waters. So global warming is essentially forcing pirates out of business. Who wants to be out on the water in that hot sun, those hot days? So as the temperature rises, we are losing pirates because of that global warming. So we need global warming to keep our seas safe from pirates. That's my conclusion. And like before, I want you to kind of think about my conclusion and let me know in class how appropriate you think that is. I'm essentially saying that global warming, the increase in temperature, is causing us to have fewer pirates on the water. What do you think about that? All right, let's kind of sum things up. I didn't want to keep you for too long on this video. Some final comments. We will discuss these issues on the first day of class. All right, please give them some thought. My whole point for showing it to you now is to save time in class so that we don't need to spend as much time in class. That's what the blended course format is all about. And if that blended course format is going to work, I really need you to come to class prepared. So you need to be watching these videos before our class. You need to be thinking about these topics and then coming to class prepared to talk. Finally, I'm really looking forward to meeting you. I will be seeing you on that first day of class, and I think we'll have a good time. That's it. Thanks, everybody.